Hi, I've reviewed both of these power supplies on my channel. The one on the left is a UNI-T UDP4303S, which I reviewed recently, and the one on the right is a UNI-T UDP3305S, which I reviewed a while back. While these two power supplies look quite similar, the price tags are drastically different. The UDP4303S is significantly more expensive than the UDP3305S. The 3305S, for example, retails for about $520 at the time of making this video, but the retail price for the 4303S is around $1,400. So with the 4303S being almost 3 times the retail price of the 3305S, there must be something more than meets the eye. After all, these two power supplies look quite similar from a glance. So in today's video, we're going to compare some of the specifications and perhaps do some real-world testing. And if you're debating which one fits your needs better, be sure to stick around, and you should be able to decide that after watching this video. Now, at a glance, these two power supplies look very similar, and that's somewhat to be expected, as they're both from UNI-T, so they do follow very similar design philosophies. Of course, they have different color schemes, but that's just for aesthetics, and has nothing to do with the functionality. What I can tell you is that these two power supplies are actually quite different, in the sense that they're of two very different designs. Of course, these two power supplies are also from two different series, so you also need to keep that in mind. The difference is actually pretty evident if you take a look at the internal constructions of these power supplies. Now, I didn't do a teardown of the UDP3305S, but the volt log channel had done a fantastic job stripping down the unit, and I'll post a couple of screenshots here, and be sure to check out volt log's video for the complete teardown. I'll put the link down below. For the UDP4303S, I did a teardown when I reviewed the power supply. I'll also leave a link to that video in the video description below as well. Anyway, you can see that the UDP4303S has quite a bit more circuitry inside. Now, the first big difference you will notice between these two power supplies is that the UDP4303S is a 4-channel power supply. You can see here 1, 2, 3, 4, whereas the UDP3305S only has 3 output channels, 1, 2, 3. Although on UNI-T's website, the UDP3305S was also referred to as a 4-channel power supply. But in my opinion, that's just a marketing gimmick, as the 4-channel they're referring to is just the USB output, which I wouldn't count as a separate channel because we also have a USB port right here as well on this UDP4303S. Anyway, both of these power supplies have 2 main channels, channel 1 and channel 2, you can see here, and they're both capable of outputting up to 33 volts. In fact, the specification says 32 volts, but the maximum set voltage can be as high as 33 volts. Let me just show you here. So for example, voltage, we can do 33 volts. The 3305S does have some advantages here, as the maximum current for channel 1 and channel 2 is specified as 5 amps versus a 3 amps maximum for the UDP4303S. Of course, just like the voltage settings, there is some margin built in. On the 3305S, you can set it as high as 5.2 amps, and on the 4303S, you can set it as high as 3.2 amps. Now, the maximum current actually can be a determinant factor when choosing your power supplies, as if you routinely need the current over 3 amps in a dual rail configuration, the UDP4303S may not even be an option. Now, I did stress dual rail configuration because with either of these power supplies, you can actually set channel 1 and channel 2 in parallel and thus double your output current. With that said, 3 amps maximum per channel is actually plenty. I actually don't remember if I ever got into a situation where 3 amps per channel is not enough. Nevertheless, for this one, you need to check your own use case and decide. As a side note, because of the higher current capacity of the main channels, the UDP3305S also has higher power rating, 348 watts versus 293 watts for the UDP4303S. The third channel on the UDP3305S can output up to 6 volts with a maximum current of 3 amps. And also you have this preset you can see very conveniently. You can cycle through different voltages as the output. Of course, you don't have to use the preset. You can always come here and set your voltage. For example, I want to do 3 volts, and you can do that. No problem at all. The 4303S has 2 additional channels. Channel 3 can output up to 15 volts, 3 amps, and channel 4 can output up to 6 volts and 10 amps. All these channels are fully adjustable, of course. So with the 2 additional channels, the UDP4303S is definitely more versatile here. Especially its 4th channel can output up to 10 amps. And with that, you should be able to power the most power-hungry TTL circuitry. Now, the question is, do you need 3 channels or 4 channels? Well, for most of the hobbyists, I think 3 channels would probably be fine. After all, you can always use more than one power supplies. There are some situations where it's more advantageous to use a single power supply to power the entire circuitry, as you can turn all the power rails on and off at the same time. And both of these power supplies support that. For example, I can turn on all power rails here, and also I can do the same thing on the 3305S as well. So in this case, obviously, it's always better to have more channels just in case. And sometimes you also need power supply sequencing, especially, for example, when powering FPGA circuitry. In this case, you can use a computer to interface with both of these power supplies to do that via skippy command. And before we go any further, let me actually show you some of the differences from the user interface perspective. Again, at a glance, the user interfaces look pretty similar between these two power supplies. But the similarity is only skin deep and somewhat to be expected, as that's just a design language of UNI-T. But as I mentioned earlier, the actual design and the firmware on these two power supplies are completely different, and you can see that after you play with these power supplies for a while. For instance, I think the user interface on the UDP3305S seems to be easier to use, and that's mainly because we don't have as much functionality on this power supply compared to the 4303S. For example, we have these dedicated buttons to configure output in series, in parallel, and it even tells you which binding posts to use. And that's definitely very intuitive. I actually like this feature a lot. Changing the output modes on the UDP4303S is arguably not as easy as on the UDP3305S. And it is slightly more involved only because we have a lot more options here. So for example, you can see, in order to change that, we have to press Option. And now you have all these options to select from. You can configure them as independent, as in series, or in parallel. And one thing that's not as intuitive is after you configure the channels in series, you come back home. Yes, you see a combined channel 1 here, but we don't have any visual indication as to which binding posts to use. So that's just something you need to pay attention to. I'm not going to go through all these options, as I have already done a detailed video on this topic, and I will link it in the card above and in the video description below for those who are interested in diving deeper with this UDP4303S. And let me change it back here. Anyway, we have some quite advanced modes here, and you can change the overcurrent delay mode, the overcurrent delay time, and so on and so forth. We also have a few more features that are not available on the UDP3305S. Let me show you that. So let me scroll down. Now, one feature that's missing on the UDP3305S is the ability to make channel 1 and channel 2 tracking each other. Now, we do have this feature. We can, for example, put these two channels in series, and in a sense, they are tracking each other, but they're also sharing the common ground. And the virtual ground in this case would be the negative side of channel 1 and the positive side of channel 2. Let's actually measure that. Let me enable the output. And let's actually set a voltage, let's say 15 volts. And let's check here. So you can see here, if I'm measuring the output voltage, it's actually 15 volts. That's the total. But if I'm measuring channel 1, you can see it's 7.5 volts. And if I'm measuring channel 2, it's also 7.5 volts. So you can actually use a series mode to power a circuitry that requires dual rail. For example, if it requires both positive and negative, this is the way you can do it. So in series mode, channel 1 and channel 2, in a sense, are tracking each other, but because we have this connection in the middle, they're actually not independent. On the 4303S, besides being able to connect channel 1 and channel 2 in series, and in parallel, of course, you can also make channel 1 and channel 2 tracking each other without connecting the two channels together. So let me actually show you that. For example, right now, let's go back here. If I turn the tracking on, now channel 1 and channel 2 are actually tracking each other. So let's go back here. So you can see the symbol here. Of course, I mentioned there is a bug. Right now, for example, it shows channel 1 is 33 volts, channel 2 is 0 volts. And if I turn it on, for example, right now, these two channels are actually outputting different voltages. And I can show you that. Right now, channel 1, for example, is 33 volts. And channel 2 probably is 0. Yep. Of course, as soon as you change the voltage setting of either channel 1 and channel 2, let's just do channel 1 for example, let's do 32 volts. And now channel 1 and channel 2 are tracking. So I think there is a minor bug here. But anyway, that's something that they can easily fix. So you can see here, channel 1 is 32. And if I turn on channel 2, you can see that channel 2 is also 32 volts as well. And of course, these two channels are fully independent. The positive side and negative sides are actually not connected. So let me just show you that. You can see that they're not connected. Whereas on the UDP3305S, the positive and negative sides are connected between these two channels. So the tracking option on the 4303S can definitely be useful in certain situations. Another feature the UDP4303S supports is remote sensing. The channel outputs are also available via the rear panel connections, which we don't have that on the UDP3305S. The UDP4303S also has the bleeder resistor option, and as the name suggests, when this feature is enabled, it places a bleeder resistor across the output terminals, and this helps the settle time and also helps discharge the output capacitor. So let me actually quickly demonstrate that for you. Yeah, let me go to option, and let's change tracking to be off first. Let's restore everything back to the original, and let's go up. Let's change them to be independent. That's good. Okay, so now let's come down here. You see that we have this option here. It says when the channel is off, whether or not the bleeder is on. Currently, the bleeder is on, so let's actually turn off the channels here. And let me show you. So here the multimeter is in resistance measurement mode, and let's measure the channel 1 output impedance here. And you can see is roughly 21 ohms. So if I turn the bleeder off, let's do that. And you can see that the output impedance increases to around 6.2K. So that's the option we have on this 4303S. We don't have on the 3305S. Let's actually take a look at the 3305S to see what the output impedance is. So let's turn off the series. And let's actually, right now all channels are off. Let's take a look at the output resistance. So you can see that the output resistance when the channel is off between the positive and negative is roughly 500 ohms on this UDP3305S. Oh, I almost forgot to mention, you can also change the sample rate. Let's go up here. You can see that we have this option current sampling rate. And changing this value would in turn change the update speed in the graphic mode. So for example, you come here, wave, and the graphic update rate here is actually determined by the maximum sampling rate here. From the specifications, we can see that the UDP4303S has better current setting and readback resolution. It is 0.1 milliamp. For the UDP3305S, it's at 1 milliamp. For both of these power supplies, the voltage setting and readback resolution is 1 millivolt. Another spec that is easily missed is the command processing time. For the UDP3305S, it's specified as 100 milliseconds, whereas for the UDP4303S, it's actually only 10 milliseconds. So this spec tells me that the 4303S has a much faster onboard microcontroller, and because of that, the list functionality is actually far superior on the 4303S compared to that on the UDP3305S. Let me actually briefly show you that. Now let's first take a look at the 3305S. You can see we have actually a dedicated button for the list and delayer. So let's press that. Here is our list. So let's go to the template. Let's go try to see how do we set the interval here. And the minimum you can set is actually 0.1 second. Now let's take a look at the list on this 4303S. So for that, I come back here. Let's actually do list. Let's go back here, template, and let's see here. Let's do interval. And you can see here, we actually can set it down to 1 millisecond. So let's do that. You can see here, of course, right now we have to change the period time. Let's do 500 milliseconds. So you can see the minimum interval on this UDP4303S can be set at 1 millisecond, whereas on this UDP3305 is actually 100 milliseconds. Using this feature, you can actually generate a very fast changing output waveform. I demonstrated this feature in my UDP4303S review. Now, as I just mentioned, you do get more options with the overvoltage and overcurrent settings on this UDP4303S. But I think the implementation of overvoltage and overcurrent selection is actually more logical on the UDP3305S. For example, in my opinion, when overvoltage and overcurrent protection is on, you shouldn't be able to set the current or voltage value higher than the OCP or OVP value. So let me actually quickly show you here on this 3305S. You'll see what I meant. So you can see here right now, for example, let's actually change the limit here. So this is actually good. For example, right now, the set value is 33 volts and the set current is 5.2 amps. But the limit is actually 1 volt and 3.2 amps. So let me see what happens if I turn on the OVP. You can see that as soon as we turn on the overvoltage protection, the set value changes down to 1 volt. That makes sense because that's the highest limit we set. And similarly with current as well. For example, if I turn the OCP on, you can see that the set current also dropped to 3.2 amps. Now, for example, if I try to adjust the set value, you can see that I cannot increase it because the OVP value is actually at 1 volt. So that's the behavior I would expect from OVP and OCP settings. But the behavior on this UDP4303S is actually quite different. For example, right now, I'm not sure you can see or not, the limit is set to 20 volts and 1 amp, whereas the output currently is set as 32 volts and 3.2 amps. So let me try to actually enable OVP here. And you can see that OVP is enabled, but we're still able to set at 32 volts. In fact, I can change that voltage. You can see here, I can change it to 31 volt, 30 volts, it doesn't really matter. It's still above the limit. Now, if I, of course, turn on the output, OVP would kick in. That's to be expected. But we could have avoided this situation altogether if the system did not allow us to set the voltage higher than the protection voltage to begin with. And the same thing applies to the overcurrent protection. So for example, if I enable this, you can see that currently the set current is higher than the limit. One issue many viewers had reported with the UDP3305S is that when the output is off, there is some residual voltage across the terminals. So let's actually verify that. So right now, all channels are off. Let's actually take a look. So you can see here, let's try to measure channel 1. We're getting, that's kind of insignificant, but we're getting 10 millivolts output. Let's do channel 2. For channel 2, the output is actually negative 240 millivolts, even though the output is off. Now, that could potentially be a problem. Let's actually see how much current we're talking about here. So let me try to short that. So let's go to milliamp. I don't think the current is that high. Let's take a look here. So the output, if I try to short it, yeah, you can see that we're only drawing about 0.5 milliamps. So in the grand scheme of things, I don't think it matters that much, but nevertheless, it's not ideal, as we do have some residual voltage, and that voltage is actually on the high side. You can see here, it's roughly 0.24 volts. So let's test the same thing on the UDP4303S. Now, of course, all the channels are off, and let's see channel 1. Yep, we don't have any readings here. Channel 2, no readings either. So definitely this issue has been addressed in the 4303S. As you can see from today's comparison, the UDP4303S is definitely positioned as a serious professional grade lab power supply. Not only does it offer one more channel compared to the UDP3305S, it also offers many more features that are not available on the 3305S. It is more precise in general, especially when it comes to current setting and readback resolution. So all in all, the UNI-T UDP4303S is definitely a great power supply. Now for hobbyists, obviously not everyone has $1,400 lying around for a power supply. So the UDP3305S remains a solid choice if you don't need the fancy features on the UDP4303S. In fact, if you don't need the high programming accuracy, you can actually choose the UDP3305S-E. And the -E version is even cheaper. And the only difference between the -E version and the standard S version is that the voltage programming accuracy for the -E version is only at 10 millivolts versus 1 millivolt for the UDP3305S. Thanks for watching this video. Hopefully now you have enough information to decide whether you need a UDP3305S-E, a 3305S, or a 4303S. I hope you find this video useful. If you liked the video, please remember to give it a big thumbs up, and don't forget to subscribe to this channel for more videos like this in the future. Your participation makes videos like this possible. Thanks for watching, and I will see you next time.